Welcome everybody. I'm Baristing, Tango Alpha 7 Whiskey or Oscar Hotel 2 Uniform Delta Sierra from Finland. Today, with my friend Barb, we will talk about the ADX, a digital QRP transceiver. Just before we start, I would like to say that I'm in this hobby for more than 30 years, and with Barb for the last few years, I had the best experience on building some small devices, thanks to him. Welcome, Barb.
Welcome. Yeah, my name is Barbaros Asaroglu. Everyone knows me as Barb. My call sign is Whiskey Bravo 2, Charlie Bravo Alpha, living in New York, USA. Yeah, it was an adventure that's going on for a long time. I'm in the hobby also, like Boris said, for almost 30 years, but I was more on VHF and UHF side of things. I never was interested in HF, but lately in 2019 onwards, I got interested with the digital modes, especially with digital modes, Whisper, FD8, FD4.
I think we will talk about that history more in detail today.
Yeah.
So, yes, today the agenda is, first we will talk about the history because it has a very interesting history behind, there's an interesting history behind this ADX transceiver. Barb will talk about that. Then we will see the specifications of the ADX transmitter. We will go through the schematics to understand the details of this device. What is special about this device, like CD2003 IC, and of course the zero crossing technique we will talk about. We will not forget to talk about the SI5351 as well. Then the CAT interface, and we will show you some simple steps about building this device and how to test it. Yep, Barb?
Yeah, so this is the history of the evolution that I tried to come from QCX all the way to ADX. So everything started with QCX, actually. I got a QCX. I modified it to micro SDX. Micro SDX is a full-blown SDR all-mode QRP transceiver. So the modifications on QCX led to work on SSB, especially, and I could use it, so digital modes also. So it came to design my own rigs, which you can see in the middle. So the first one is the micro SDX mono, and then it became micro SDX soda with ATU, etc. The problem I had here was micro SDX is a very good rig, but it's like using, when on digital modes, going to your supermarket, like 300 feet away, with your Ferrari. I was using only the digital modes, and I wasn't using anything else. So I put my head to kind of design something that's basically does only digital modes. Then QDX came. And when I watched the video of QDX, I said, this is the gadget that I should try to design. And that's a great, great product, only dedicated to digital modes. Without gimmicks, nothing doing else, that's it. So that's how ADX project started. I wanted to build something similar to QDX, but I don't have the skills, neither the firmware skills Hans has. So I said, okay, I'll strip it down as much as I can and produce something very, very simple. So,
and you did. Thank you very much. Yeah, the specifications.
So, yeah. The specifications of ADX is it works between HF bands up to 30 megahertz using appropriate LPF field filters from 80 meter to 10 meter, which means that we are changing LPF filters in the basic ADX to cover every band. It outputs roughly 5 watts on it, and it works with the common digital modes softwares like WSJTX, JTX, MSHP, and FLDG software. It has a CAT well, it doesn't have a CAT interface, but soon it will have a CAT interface. Hopefully, Barish is helping on that. Supports Whisper, GS8, FT4, and FT8 modes. Why 4 modes? Because these are the most popular modes. So I had to keep the interface as simple as possible. So that's why I sacrificed the other modes, and I said, this thing can work only on these 4 modes that everyone is kind of working on it now. So it works with 12-volt power supply. No audio interface is required, like Rig Expert, signaling, Rig Blaster. It just connects ADX jacks straight with a 3.5 millimeter jacked cables to your PC, and it works. Well, to operate it, you don't need a CAT. So there is no USB, no CAT, no interface needed. At this stage, it can operate flawlessly.
Great. And also you can find building details on the given address below from Untrack. If we first check the schematics, we have 6 main parts in the device, which are the speaker microphone interface, the Arduino microcontroller, transmitter, receiver, and a local oscillator driving those, and a low-pass filter. That's all we have. And Bob tried to keep everything as simple as possible as far as I see. So if you go over them one by one, first I would like to say the speaker microphone interface is just an interface to get only 500 to 3.5 kilohertz, 500 hertz to 3.5 kilohertz with a bandpass filter. And that's it. That's a simple circuit that everybody can understand. So even without those, it works. But having those filters there is a good thing. So I will not talk about the details of that. Then the low-pass filter, it's the standard low-pass filter used in USDX and the others and all other products of Barb. Maybe Barb, you would like to?
Yeah, this is the serial resonance type Class C LPF. So it has the design was, I think, mastered by N7V Dantaloe in NorCal. And then we took it to microSDX, thanks to Manuel, actually, DL2 man, who brought it. And I said, why not invent something else? Just use that. So, and it works perfectly good. You know, it suits everything that simple rig needs. It's very simple.
Yeah.
Tuning is a bit of a problem, but if you tune Class E amplifiers, as everyone knows, it works like a charm.
Yeah, and all the details are on the web page, so you can go through them. So low-pass filter, if you ever built a USDX or others, micro SDX or others, you know how to build that low-pass filter. Next thing is the Arduino, where everybody knows Arduinos nowadays because it's a very cheap microcomputer and all the program is running on that. And there is a very, how can I say, not complicated, I don't want to say simple, but not complicated software running on Arduino. So Arduino is capable to do a lot in this design. So the main parts that we will talk about will be the receiver, the transmitter, and the oscillator now. So when we go to the receiver, it's based on the CD 2003 IC, which was in our handheld radios, let's say 20, 30 years ago, as you see in the picture. And they are really cheap and they do real good job. And they have everything needed to build this kind of simple receiver, direct conversion receiver, I can say. Normally the test circuit in the datasheet of CD 2003 is as follows. So you see a lot of coils, a lot of variable capacitors. So it's not easy to build this kind of device and make it working for most of us, because just building those coils are a real headache. Then there is another schematic, or there's another test circuit in the datasheet. It's much more simpler. So I think, Barb, you choose this one to be the base of
Yes, yes,
the
yes. I mean, we just use the AM RF preamplifier section. This is an AM FM chip. So we use only the AM RF preamplifier section and the mixer. So it works like a direct conversion receiver. That's all there.
Yeah. And here you can see the details of that receiver as it's in ADX, the application of this CD2003. Here, when we go one by one, you see in the center we have the CD2003, and we have not many components surrounding that chip, but on the bottom side you will see a transistor, how can I say, controlling the RxTX switching. It switches the antenna between the receiver and the transmitter. So it's just a switch. We can just get rid of that to understand the receiver. And you can think that the antenna is directly connected to C11, and it goes to the chip. On the right, upper right side here, you can see this is a DC filter. So if you are using a, how can I say, noisy power supply, you can keep the AM receiver not to be affected from this noisy power supply by using this
especially when you are using with Arduino. Arduino kind of inserts some unwanted signals. So I had to add that to eliminate those signals.
Great. And so that DC filter removed, this is the receiver. As you see, a few capacitors, a few resistors and diodes, and one coil, which you can think that how will I make this 1 microhenry coil, but it's very simple to build that coil, and it's all explained. So it's just winding a wire in a T37, I guess it was.
Yeah, 237 too. Actually, it can be a fixed inductor also. Okay, when we come to the other part, okay, I'll explain it more in detail. But yeah,
then
that's just a shock. Yeah, that's just the shock.
What we have here is we get the RF signal from the antenna. We have a local oscillator signal coming from the SI5351, and what happens here is we just mix those and get the audio baseband audio output, and the rest is the computer's mission to decode, do some digital signal processing and decode the signals. Here I would like to show, maybe most of you already know, the VSJT. What it does is, where you put your cosine and you start using it, and it receives the signals within the audio band and decodes what's going on in there. So you can have a lot of stations even within a 3 kilohertz bandwidth. As you see here, for example, here we can see 800 to 2 kilohertz, and there are many stations sending and receiving. Here you see the signals, different frequency signals. So the base frequency is, for example, 14.074, but then on the audio side you have some extra signals, tones on the top of that carrier. So first, it's not easy to pass this information from computer side to the device. Yes, we may have developed another software which tells the device to transmit which tone, but everybody is used to, everybody knows this VSJT and the others for FT8, FT4 and things. So I think, Barb, you decided to have it as it is, so you didn't want to change people's
no.
environment.
No. What I'm trying to do in this is to get the tones in real time from the WSJTX that transmits and get it into Arduino and use it in a zero crossing comparator fashion, which Barish is going to explain now.
Yeah. So how we do it, normally when you have a signal, let's say 1 kilohertz, you have to measure that frequency somehow with an Arduino. And
Yes.
how you can do it, you can just count the peaks, how many peaks were there in 1 second, then you can find the frequency, but that will take some time. Or you can count the time between the peaks and say this is the period, so I can find the frequency. But there is another easy way for this. This tiny chip Atmega 328P, which is the Arduino itself, has a very good analog comparator inside with some interrupts. So when you tell this device to compare the voltage level, let's say with 0 volts, then you have interrupts on every zero crossing point. So you know you can count the time between these zero crossing points, and then you can easily calculate the frequency of that signal. That signal, we mean the signal coming from the VSJT to the ADX. So we know which exact frequency that ADX is, VSJT is giving to us. So we tell the rest of the system, please use this frequency. How we do it? We have the Magic SI5351 signal generator. So assume that we have a base frequency 14.074. Then we have a 1.420 kilohertz coming from the VSJT side. So we add this on the top of the base frequency, and we have the tone frequency for ourselves, and we tell the SI5351 to transmit on that frequency. Here you can see we get that information from Arduino to the system with an I2C interface, and S0 interface goes to the transmitting side for us. So yeah, that's the duty of SI5351. Then it comes to the RF amplifier. SI5351 is giving out the radio frequency with a power of a few milliwatts, maybe less.
Yeah, it's most importantly, it's 3.3 volts. So we have to buffer it.
Yeah, we have to bump it up. So there is an 74ACT244 here just for bumping the signal up to 5 volts. Of course, a square wave, because SI5351 is generating a square wave. And after this 74244, it's much more, I can say, it's a switch. So switching a 5 volt with that signal might give you a square wave of 50 milliwatts. Then here we have the another magic component, BS170, which if you parallel 3 of them, you can have up to 5 watts. But don't forget, here 5 watt is still square wave, so you need to use a low pass filter to make it back to sinusoidal and get rid of the second, third, and all other harmonics. Yep, so easily you can go from 1 milliwatt to, let's say, 5 watts in this simple circuit.
Yeah, so I mean, I'm making that joke. I mean, in other presentations I did. So basically, up to here, we create a glorious 30 megahertz switching supply. Yeah. That's what it is. Yeah. You know, until it goes into the LPF, which converts it into.
In reality, it's a good noise source, but after the LPF, it becomes a transmitter.
Yeah. Transmittable signal. Yeah.
Yep. We discussed with Bob to prepare a CAT interface, computer-aided transceiver interface for this tiny device, and we did. So with the new features, it emulates the TS2000, because I have a TS2000. It's easy to develop that for me. So now when you change the frequency on the computer side, the device changes the frequency. When you change the mode or frequency on the device side by pressing some buttons on it, then it informs the it informs the PC side about this change, and on the VSJT you see the new frequency on the display. Yep, that's all about the CAT interface. So how we can build one bar?
Okay, yeah. So this is a two PCB rig, actually, basically. There's a main PCB, as you see here. So the main PCB has all the components. All are true hole device components, so anyone can solder with any soldering iron. I don't think that there will be any problems on that. On the other side, we have a 5 LED interface and 3 switches, as you see. So 2 of the switches are changing the modes and bands, and the switch at the bottom is the TX switch. So it's just to transmit without using any, WSJTX or anything for testing the rig or for tuning facilities. On the top, you can see the modes, the 4 modes it operates, also the 4 bands. So the LEDs have 2 functions. It can show which band is selected, or it can show which mode is selected. So all the details are given in the article. I don't want to go too much detail in that. It will be too long. So the other thing is the LPF module, if Boris, you can, yeah. Oh, also, I don't like cases because cases are problematic to, I'm not a 3D printer guy or anything. So I found this method is easier for me. So I designed PCB faceplates, I call it, to the bottom and the top of the thing using standoffs. It becomes, I'll show you here, something like that.
I have a tinier one.
And he has a new version, yeah, the tinier one.
The Pico.
So, yeah, I mean, it's a very easy rig to build, And today, in these days, PCB production is not a problem either. I mean, the Chinese PCB houses are doing it very cheap. So this is the finished ADX. So you can see all the components. There isn't too much in it. This is at the bottom. You see that little choke of 1 microhenry. And on the top, you see the LPF filter module. So the rig firmware supports 4 bands. So you can change the bands and mix and match any bands, The only important thing is you have to change this LPF filter to suit the band you selected. That's the only part. And that's it. The rig works on that part then.
Yeah, and if you ask how easy is building a device like this, I can say this is my wife, Oscar Hotel 2 Charlie Alpha Victor, or Tango Alpha 2 November Bravo Alpha. She's not an experienced electronics guy doing this kind of job every day. She's a software engineer. But in this picture, you can see she is building the device, because when Bob gave me this device first, I said how easy it is. He said it's very easy to build it. So I tested it, and yes, it's very easy because my wife built this in a few hours easily, even the coils. And the right side shows all the stations receiving. I can say I don't have an antenna for HF for this testing, so it was just a cable outside of our house, just receiving all these stations, and it was unbelievable to see all this. Thanks, Barb. It was a very good experience for us.
You're welcome. Yeah, I mean, I created this to be simple to with 4S rules, I call it. Simple to build, simple to procure, simple to test and calibrate, and simple to operate.
That's great. That's great. Thank you very much.
Thank you.
And I think it's time for the questions and thank you.
Answers. Yeah.
Recording stopped.
Yes, we don't have any questions in the chat area, or I'm doing something wrong. Barb, but if any questions, please type it into the chat area that we will answer. Yes, the first question comes from Bill, K3BEB. Is there a kit available? First, I would like to say that, let's get this question to screen. Not a ready kit available yet, but it's all open source, so you can download and develop your own kit. manufacture your own kit. Maybe, Barb, you can talk about the kits. Will there be any kit in the US for selling? Barb is in Spain, so he has a very bad internet connection. Most probably, he will try to reconnect again before he comes back. As I see, he's frozen on my screen. So yeah, maybe somebody can manufacture kits
Me now,
for
Boris?
Barb. As far as I know, Barb's previous designs were copied by the Chinese, and you can buy from Ali or other Chinese sites. Barb, please
You
go on.
can hear me now, right? Yeah, my internet
Yep.
connection is very choppy, so it just kicked me off. Yeah, I mean, Keith Talon is. I designed another one. It's called ADX Uno. So this is kind of a hat that plugs in. Its shield plugs in Arduino Uno. So Keith Talon said that, hey, this is a good kit, so I'm going to, sell it as a kit. And I said, go ahead. I'm not selling kits. So yeah, there will be kit for that thing. It's not the design that we showed. It's the basic one, what we showed. So, okay, I see the question, where do we purchase a kit? Well, it is still not a kit. I'm still working on it. I have to write the build manual, etc. So it is not, that's the Pico, that's a different one, but it's small. It is not on the market yet, but hopefully in a couple of weeks, Keith Talon will do it. It's, if you guys know the UCX micro SDX group in IO groups, you will see the chatter there about this kit. Keith is doing it for fun, so we are not like established kit sellers or anything. I'm not selling anything anyway. He does it. So what we do is we announce it in the micro SDX group, and everyone's who interested, kind of. Actually, micro SDX group. Maybe Boris, you can pull up the link to post here. I don't know if it's possible to do it now.
Yeah, I just put it down below the ADX build
Yeah,
instruction from Untrack
yeah,
website.
yeah. So yeah, it will be like that. But ordering PCBs and building the one that's posted as on my blog and Ankrag is very easy. It's just you can get like 10 PCBs for $5 and 5 PCBs for $2 plus shipping. Of course, the shipping is the killer, but if a couple of guys come together, it's easier. They can share the cost, what they do in the clubs mostly.
Yeah, most of the questions are about how to purchase it, how to buy it. Is there a kit? Like the
Yeah.
question from Bill. Then George asked a similar question, KJ6TSX. Then Robert, KF6ABC, asked, where do we buy one? And yes,
Hopefully
Nicholas,
it will be a kit, and I hope Chinese will pick it up, and there won't be any problem like through
yeah, I
SCX.
think Chinese will copy it as soon as possible when they
Yeah,
have it copy.
yeah.
The project website is the Untrack.
The Untrack also check WB2CBA, Whiskey Bravo 2 Charlie Bravo Alpha GitHub page. If you write that GitHub Whiskey Bravo 2 Charlie Bravo Alpha, you come up with my GitHub page, and it's there. It's called ADX. You can't miss it.
Yeah, now I will put that message to the screen as well. By the way, we have another question. Maybe you would like to answer that.
Yeah.
It's from Yako AC1BD. 5-volt operation. What output power?
Oh, that's a good question, because I was curious about that, and I did that actually not long ago, like a week ago or so. Instead of 12 volts, I connected the LPF to 5 volts. Believe it or not, I can get 1 watt out of it, and for 5 volts, 1 watt is pretty good, and it consumes 225 milliamps, which means you can kind of power it with the USB itself. So that's another day's project, maybe.
Yeah, good. I just put the project page on screen.
Yeah,
It's github.com/WB2CBA. Another question from Voyaslav. I hope I pronounce it right.
yeah.
Yankee Uniform 4 Hotel Alpha Kilo. It was very easy to source parts for this kit. You can find everything on Ali and boards on GLPCB. I built everything but the filters. I hope to finish it soon. Good.
That's
Somebody.
great to hear. Yeah.
Yeah,
I
great
mean,
to hear.
my idea was not to be hit by the chip shortage. So everything on that thing is, I mean, you are using, of course, SI5351 is hard to find now as a chip, but the SI5351 clone modules of Adafruit is everywhere. You know, it's easily can be bought. So that's the most crucial part. The rest is Arduino, CD3, 2003, the receiver you see on eBay, like 10 of them for $4 or whatever.
Yeah, and I think in total it's less than or something around 30
Yeah,
bucks
30, yeah,
for
30
the
bucks.
whole
Yeah,
device.
something like $30. Yeah.
And believe or not, as we presented, my wife just built one, and after just finishing the thing, normally you have problems. You have to debug it. You have to get it running, but it ran just after building it, and she connected that to an antenna and a computer, and she started QSOing. That was great.
Yeah, I mean, I get always the question. I know it's not there, but how can I say serious is this rig? So, well, it's an experimental rig. It's a very simple rig, but how serious it is, I'll give you an example. I gifted to a friend of mine. He ran this ring for I think 5 weeks and did 780 QSOs with ATX. It's incredible.
Yeah. What kind
And
of antenna he used?
he used an NFET, no tune NFET, on 20 meters. And he has, I mean, he's living literally on basement level in between two apartments. The antenna is hidden. And he has, I think, 2 or 3 New Zealand and couple of Australia. And this is from Turkey to Australia.
Great.
Yeah.
Yeah, this digital modes, they are great.
Yeah, they go pretty good with low power.
Yeah, and no more questions in the chat area. I think um, I can bring up the project page again. Maybe people might want to visit, see the schematics, the software, everything's there. So you can just procure the components and start building one for yourself.
Yeah, the other thing is this is not a RF challenging rig, so you can even build it in a breadboard easily.
And as far as I know, you have some test routines built in already for testing the how can I
Yeah,
say the
there's not yeah exactly. I mean, there's nothing much to test actually. The interface is very simple. It's LEDs, so the only thing we do is the calibration, and calibration is with a 1 megahertz signal, and 1 megahertz signal can be measured with many inferior measuring tools. So like 10 megahertz scopes or 1 megahertz frequency counters that they are selling for $10 in Ali.
Yep.
That's the only thing you calibrate. That's it.
Okay, Bob, thank you for joining us. And your
You're
internet is
welcome.
from Spain as well.
Yeah. I mean, yeah, exactly. The hotel internet is not that reliable, so we survived.
So if no other questions, yes, one more.
Okay.
David, Whiskey Zero Delta Fox asking, what's next for you, Bob?
What's next for me? Oh, that's a good question.
Building kits every week.
Yeah. I mean, I want to work on this ADX a little bit more to make it multi-band. I'm thinking that if you design the cat brush, or anyone designs, actually, I know that Pedro, my friend in Argentina, is working. Actually, he did design a cat routine for it, but I didn't have time to test it because of my day-to-day life. and work. So like 4 bands auto switch. Hans will be angry, but something like QDX, coming close to QDX, not QDX. Yeah.
Yeah, I think they are not in the same segment, but this is
No,
a
they
very,
are not. No, definitely they
very
are not.
simple but very
I mean,
powerful
uh,
gadget.
yeah. I mean, I did a presentation to a Canadian club, and they asked me, "Oh, this is QDX." No, QDX is a Ferrari of those rigs. Mine is a bicycle. When compared to QDX,
Yeah, well,
yeah, they go from A to B, but with different means. Definitely,
yeah,
it's
and I
not
like this.
QDX.
I mostly like this Pico one. I carried
Yeah.
this.
Yeah, I'm
Like
going to write a blog and release that one. So yeah, that's an assembly version.
yeah,
Like
it's a good pocket version.
yeah,
You can
bucket.
carry it
Yeah,
anywhere,
yeah,
and you can just
yeah,
run it and make QSS anywhere you want.
yeah.
Yep, David says Whiskey Zero DF. Thanks for the interesting program, gentlemen. You're welcome. Thank you.
You're welcome. Thank you. Yeah. Much appreciated.
Waiting for questions. If no questions, I think we will end the stream. No, thank you, Bob. It was good
You're
to
welcome.
understand.
Thank you. Thank you for everyone watching.
Yes, as David said, let's see what next, Bob.
Yeah. Well, if my job is a bit hectic. So if I find time, I'll definitely release whenever I build something. So you guys know me. So yeah, you'll see it.
Okay, thanks everybody for listening us. Maybe see you in another presentation.
Yeah. See you. Bye.
Yeah. Welcome everybody. I'm Boris Dink.